How's it going, Geometry Cats? Today we are learning about 12.2 chords and arcs. Okay, so we're going to learn about boats and things you play on guitar and piano. Anywho, a chord is any segment, line segment that is, whose endpoints lie on a circle. Okay? So right here I have a chord because it goes from P to Q. Okay? This would be a chord. This would be a chord. This would be a Honda Accord. Okay. Right. This would be a chord. In fact, it's a special type of chord called the diameter. The diameter is a chord that passes through the center. Okay? So not all chords are the same length. So this one's going to be a lot shorter than this one. Okay? Something to keep in mind. Theorem 12.4 and its converse. Within a circle, okay, if these angles are congruent, then these arcs are congruent. Okay? That makes sense, right? Same central angle, you have the same arc measure. If you have the same arc measure, you have the same central angle. If this was 35 degrees, my arc measure would be 35 degrees. So if this was 35, that was 35, 35, they're all the same, right? Now if this is 35 degrees and this is 5 feet long, then this one would be 5 feet long because it's the same angle, okay? Same theory over again. Except for this time it says if these angles are congruent, these chords are congruent because it's the same as the arc measure. It's there, it's straightforward, it's geometry, it's math. Anyway. Are we getting that? Congruent angles, congruent central angles, congruent chords, congruent arc measure. I'll show you more about it in a little bit. Okay. One more. And the converse says that if the arcs are congruent, if the chords are congruent, then the arc measures are congruent. Which makes sense. Let's just do some examples. Okay. So we have O and P. We know that OBC is congruent to PDF. So these two angles are congruent. How can you show angle O is congruent to P? And what else can you conclude? Very interesting, very interesting, very interesting. Okay. So we have congruent circles, right? Right? So how we could show that that angle is congruent is by finding out if BC is congruent to DF, then then your arc BC be congruent to your arc DF, and if your arc's congruent, your chords are congruent, and your triangles are or your circles are the same size, then those angles are congruent. Okay, that's all there is to it. Okay. 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 Theorem 12.7. This one's a little bit different. In fact, let's blow it up a little bit. Yeah, actually, I'm gonna blow it up. Ooh, okay. Okay. What this one says is I have highlighted there. It's a poor choice. Poor choice. What it says is if you have two chords, if your center is equidistant away from each chord, then the chords are congruent. Okay? What that means is if you draw a perpendicular line from the center to your chord, and then a perpendicular line from your center to another chord, and those are congruent, then your chords are congruent. I'm going to show you why. You're going to say, Mr. Will, I'm really confused right now. I'm trying to understand this probably tough section in the chapter. This is an isosceles triangle, right? And this is an isosceles triangle, right? Because all radii are equal in a circle. Well, this is an isosceles triangle where these two sides are congruent and these two sides are they're all the same. They're the same triangle. That's what it comes down to. Let's do an example. Well, let's blow it up a little bit. Okay. What's the value of x? Well, I take a look at this circle here. You see, this guy is 36, right? 18 plus 18 is 36. This chord is also 36. So my chords are the same length. So that means my x, if this is 16, my x has to be 16. Okay? Because my chords are congruent. And if they're congruent, the center is equidistant away from both. Okay? More theorems. This, man, I tell you what. Why did I make any of these like a good size? Okay. In a circle, if you have a diameter and it's perpendicular to a chord, then it cuts that chord and it cuts the arc it creates in half. What I mean by that is if this is diameter, it's going to cut this line in half and it's going to cut that part of the circle in half. Okay? And vice versa, if it cuts in half, then it's perpendicular. It works both ways. Okay? So take a second, read that, digest it. And the last corollary to that one is, if you have a chord and it is perpendicular to another chord and it bisects, perpendicular bisector, then it contains the center and is a diameter. Let's do some problems. Okay, first one. Find the value of x to the nearest tenth. Let's take a look at this beast. X is this length from here to here. Well, let's think about this. This is 20. What's this half going to be over here? 10, right? Now it's perpendicular, right? And it touches the center. So what does it do to this segment? Well, it cuts in half, right? So I have a right triangle, right? And I have a hypotenuse. So I can set my hypotenuse squared equals my leg squared plus leg squared. So I get 100 equals 64 plus x squared. 36 equals x squared. Or you should have known by now that that's a 6, 8, 10, 3, 4, 5 triangle, guys. Well, let's try this one. Okay. This is 3.6, right? This whole chord is 8. So I know from here to here is 4, right? Now I'm looking for x. Oh no, what do I do? There's no... it's so hard. X is a radius, right? All radii are created equal. So I could draw something here and label this x. And then guess what? Pythagorean theorem time. 3.6 squared plus 4 squared equals x squared. 3.6 squared, that's times itself. 12.96. 12. I'm not look your biscuit. 12.96. That's why I'm using my laptop. One more time. 12.96 plus it would be 8.96. Square root it. I'm not using this one anymore, guys. Maybe cube root but no square root. Really? About 5.4. So x is about 5.4, guys. Pythagorean theorem at work once again. Okay. Square root goes next. Okay. And last one. We're looking for x, right? Perpendicular, so I know it cuts this into two equal parts. So I'm going to call this side y for now, because we have to find y first. Okay? It's going to be 6 root 3. I'm going to use Pythagorean theorem. 12 squared equals 6 squared plus y squared, because we're looking for one of the shorter sides. So we go 144 equals 36 plus y squared. So I get 108 equals y squared. So y equals 10.4. But we're looking for the whole length. So if this is 10.4, then this side's 10.4. So x is 10.4 plus 10.4 is 20.8. Okay? That's all there is to it. Enjoy.